Hello there. Today I wanted to discuss the topic of Normalized RU. This is a conversation that I had with way too many customers that looked at a 100% normalized RU and kept coming back to me and asking, I'm seeing like 100% normalized RU, is this bad? Do I need like to increase my RUs? And so I want to pause here and take a time to understand what normalize RU means and go through like just some scenarios where we are going to analyze and normalize RUs. Okay. So usually the conversation starts when customers look at the portal, they come to insights and they see like some periods of time where the normalized RU in shows like 100%. So I always start asking customer, okay, is this happening across like what is the container that we're seeing like normalizer you? Because if I select the database like VectorDB, in this case, I can see that normalizer you once went like to 10% for one of the containers that database. So it's definitely not the database that holds the container that's spiking to 100% normalizer you. So we need to narrow down exactly, okay, like which container that normalizer RU, the 100% normalizer RU is coming from. Of course, I do manage these workloads. I know exactly which one it is. So in this case, I'm going to look at like Databricks loads that I did and walk through like the analysis, okay? Before we go there, it's really important to understand what is normalized RU. We have this documentation that explain how you can monitor that, but most important is the metric definition. So normalized RU will be a factor of the utilized RU and your total RU capacity that is provisioned at that specific point in time. So if you have 10,000 RUs as your maximum throughput and you consume 9,000 RUs, that means that your normalized RU is 90%. But just bear in mind that is a factor of the current provision throughput. So if you have like auto scale, you need to take into account what is the current provision throughputs that you have for your collection in order to assess, okay, like out of that, what is my normalizer U, okay? And the normalizer U will take into account the maximum across all your physical partitions. So if you have like one physical partition that went like to 100%, but others stay low, you're still gonna see 100% normalized RU in the portal. So it's really important to narrow down, okay, is this a hot partition scenario or not when you're doing that analysis. So how do we approach this from a metrics perspective? Okay, for this example, I will be referring to the DBR load container, and it has a configuration of auto scale, and it can go up like to 50,000 RUs. So my auto scale range is from 5,000 to 50,000 RUs in this scenario. So if I go to metrics, usually where I start is just to go like, okay, what is like my normalized audio consumption the last like 24 hours. I want to take a look at those two occurrences. So I'm narrowing down the time frame here. And the first thing that I want to call out is understand like what is the granularity that you are selecting. Because if I look like a granularity to be, let's say like 1 hour, you may look like you had like a flat consumption like across the hour to like 100% normalizer you. So as you go down like the metric and like to 5 minutes and you apply, now you're gonna see like a different behavior. Like you didn't stay like 100% normalizer you all the time. You had a spike, you went down, and you had like another spike. So as I usually suggest customer, look at a finer granularity to understand what you are seeing over there. Okay, let's take like the second occurrence first. Okay, here I can see normalize RU reach like 100%, but what does it mean? Right? So I want to add like a new chart here, and I want to look at the metric provision throughput. So provision throughput will give me a metric that shows, let me go like just widen a little bit my time frame here. So like 6:30 to 7 p.m. What I want to show here is that like provision throughput is a metric that shows for collections that you have like auto scale what is the current value for your provision throughput. So it's really important like as we go through like the normalized RU that I always filter to get like my collection. So I want to get like DBR loads and I want to add the same filter here. I want to have a DBR load as well. Perfect. What you notice is that first of all there is a delay in the provision throughput. So provision throughput, if you look like at the data points that I got here, they are always gathered in 5 minute intervals. So I can see like 6:32, 6:37, 6:42, and like and after that like at 6:47. So the metric is actually completely you see that after a small delay because like the graphics will never align because normalizer you can go up to like 5 minutes interval while sorry the provision throughput is a 5 minute interval granularity, that's the minimum, and normalizer you can be like per minute. But the important factor here is that when you have like a workload that keep running for like an extended period of time, you will see like okay increase in RUs, and then you'll be able to do like a more like a closer correlation between those. But for these workloads, what matters to me is that when I look at provision throughputs, my maximum, it reaches a total of 50,000 RUs. So it means that that workload that was executing, when it reached 100% normalized RU, it did indeed push the auto scale to the maximum limits that I have for that container. Okay, so yes, I'm seeing like 100% normalized RU, and I push the limits to the maximum. What did it cause to my workload? So I'm gonna add like a new chart here, and I'm gonna see like total requests. I want to filter by my database, so I'm filtering by DBR loads. And not only that, now I want to apply splitting, and I will do a combination of operation type and status codes. So I'm gonna select operation type and status code. So why I'm doing that? I want to understand the characteristics of the workloads that drove my consumption to spike. I was doing like ingestion from Databricks. So as you can see, at this specific point in time, I have like a really high volume of, not a really high volume of requests that almost reach 300,000 requests per minute. That's my granularity that I have over there. But you can notice that at the same time, the number of upserts that I had was upserts with throttling, that's a 4 to 9 that I had, was really high as well. So if I took the ratio, it's about like 23% of my the requests that landed in Cosmos DB were throttle compared to my total. So if I take a look at the combination of my provision throughput went to the maximum for my container, I saw 100% normalized RU, and I saw like a 23% of the requests they throttled. That's not a workload that I will look at and say that's a healthy workload. No, we need to do something differently. We need to review the workload, indexing policies, or if I don't have enough RUs provision to sustain the load, right? That may be the case. You may be like under provision in Cosmos DB. But the key point here is that, yeah, this normalizer RU, it doesn't look healthy, and you need to review and make sure that you can make change to treat this workload better and accommodate the necessary amount of RUs for the workload. Okay, that's one of the scenarios. So this is what I'll call like a bad 100% normalized RU because it has consequences and a really high level of throttling, and it's not a single spike. You can see that it continues to throttle until the workload dies down. Okay. Now let's take a different time frame. Okay, I want to like undo my zoom here. I want to look at the second spike. So not the second, the first spike when I saw the normalized RU. Okay, so if I look at the normalized RU metric here, you're gonna notice that okay, I got 93%. 91, 100%, 92, 100%, but my workload was consistently high in terms of normalized RU. Does that mean that I cannot accommodate more requests? Is that like a bad sign? I cannot look at normalized RU in isolation. I do need to compare with other metrics. So the first one that I want to show to you is the actual like provision throughput. So if I look at provision throughput, what you're gonna see like after the workload starts, my provision throughput, let me expand that a little bit, my time frame here. So if I look at provision throughput, what you're going to notice that like it went up to like 21,000, 23,000, 23,000, and then it dials down. So even having 50k RUs to be used, this workload didn't push my RU usage to get to 50k. So what it means is that when I look at normalized RU being 100% here, it's 100% of a certain threshold that is like half of the total that I can scale up to. And I can see that in the distribution of uh, operation types and status codes. Remember that the previous one, I had like the pink line that showed like a really high level of throttling. In these workloads, I am sustaining like my upsurds at this level, and I don't see like any throttling, or actually like, yeah, if I look at upsurds, I got zero throttling being returned to those upsurd operations. This looks to me a really healthy workload. So let's assume that the ingestion that I'm doing like through Databricks is achieving the desired number of like documents written like per second or per minute for these workloads. And I don't see like throttling. I still have room to grow in terms of RUs because I'm only using like less than half of my amount of allowed RUs budget for that collection. That is like 50k. So when I look at uh, that scenario, the 100% normalized RU is actually great. I'm using some budgets in terms of RUs, but like I still can accommodate other requests that may land in Cosmos DB, that specific container, at the same time. So looking at like 100% RU utilization in this scenario is not something bad. It's on the contrary, it looks like a great workload to me. And just to add like one more step here, if I apply splitting by partition key range ID, when I look at the distribution of the normalized RU across my partition key range, what you're going to notice is that that one that reached like 93% utilization, I had two partitions that get to 93% utilization. Other partitions are hovering about around like 75, 86%, so like a good use. But as I look like across time, the workload seems to be like well balanced across like my physical partitions. So I don't have like a hot partition scenario in this case. So it looks to me that 100% normalized RU is a good 100% normalized RU and well distributed across the physical partitions. So to wrap up like this presentation, the general idea is that when you notice like 100% normalized RU, you need to dig a little bit deeper and see if that's like bad 100% normalized RU where you're throttling all the time and you're going well beyond like your provision throughput, or if you still have room to grow, and you can allocate uh, not allocate, you have more like space to accommodate new requests that are coming to Cosmos DB. So bear in mind that 100% normalized RU is not always bad. Just take a step further and just combine the provision throughput and look at your like request profile by operation type and status codes to get a deeper sense if that's a good or bad normalized RU. I hope that was interesting, and yeah, maybe see you in a future recording. Thank you.